Good morning. So far, I'm just talking to myself. So we'll see what happens here. I'm going to wait a few minutes. Hi, Rocky. It's good being number one, isn't it? All right. Make sure you guys are, make sure you're communicating with your classmates about times to get on. Okay. And for example, and the way we're going to do this, I've changed the way we're doing science, and pretty much every teacher has. By the way, say hello to Harold. Hi, Harold. Say hi, Harold. We are going to do 8th grade at 10 o'clock. It's a 20 to 30 minute session. 7th grade at 11 o'clock, and that'll be a 20 to 30 minute session, and 6th grade at 12 noon, and that'll also be a 20 to 30 minute session. I don't know. We don't have anybody in here but you. So have you gone into Google Classroom at all to see what was there? You should be going to Google Classroom to see what assignments are there. There's actually should be a couple. One is based off of Quizlet. The other is assignment on, it is called opposing friction. You didn't look in science yet, that's okay. You Cosmic or Fireball? So what I'm going to do is what I'm going to do is just talk about a few concepts, key concepts, and this will help you do the assignment that's in there. Number one, we've been talking about forces. We started off talking about forces on Tuesday, and I don't remember if you were in the session or not. First of all, what is a force? A force, really simply, we'd call it either a push or a pull. A force can pull you, a force can push you. One of the most common things, one of the first things you learn about a force when you're in elementary school is gravity. We know if we have something and we let go of it, it's going to fall. We think of it as falling. Actually, it's being pulled to the earth. That's an invisible force, and it's a pull. And good morning, Mr. Foss Knight. There's another person that's logged in. If you've logged in, please let me know who's here. So we're doing a quick review. We're talking about what a force is. A force can be a push or a pull. And who's me though? A force can be a push or a pull, and then so we're going to actually start in talking about friction. Friction, we all talk about friction when we rub our hands together. We learned that in elementary school, right? And what happens when we keep rubbing our hands together? Our hands get hot. That's caused by friction. But how does friction help us? Hi, Madison. If you guys are in 7th grade, come back at 11. I'm going to be we're breaking this into smaller sessions. I appreciate you being here. I really do. We're going to break this into smaller sessions. We're going to do 20 to 30 minutes at a time. So Tuesdays and Thursdays, 8th grade at 10, 7th grade at 11, 6th grade at 12 noon. So I appreciate you guys showing up. You're welcome to hang around, but you do not need to be. I would appreciate you being on at the appropriate time for your grade. So we are talking about friction, and we know some basic things about friction, but we don't know how friction helps us or hurts us. So a couple things, there are actually 4 different types of friction that we're going to talk about. Some are obvious, and some aren't. When we walk, friction keeps us from slipping and sliding. Every time we take a step on a surface, and pardon me for my rudimentary things, but every time we take a step on a surface, borrowed my daughter's shoe for this. Somebody's going to say something about shoes, aren't you? We have what's called static friction. And static friction is when a force is applied and the object doesn't move. And of course, that's what we want when we're walking. We want static friction. Hey. There you go. They're not mine, I'm sorry. I raided my daughter's closet. You wouldn't want to see my shoes. You guys know that already. All right, my $10 shoes. And so friction, when we're talking about static friction is when something actually sticks to the surface like we want it to. I'm famous, huh, Rocky? Can anybody think of another example of static friction when we actually want it to occur? So rack your brains there. I'm going to wait a second and see if you can come up with anything. In the meantime, I'm going to talk about the opposite of that, which would be sliding friction. If it's rainy out, and I know I talked about this a little bit on Tuesday, but there wasn't very many people on. If it's rainy out or if it's snowing and you're outside and you take a step, let me use a little bit of ice, what happens? Instead of that shoe sticking, you're sliding across. So a car is a good example. A car is a good example where we want friction, right? What part of the car? We want the tires to be have static friction with the ground because we don't want the car to slide. I gave the example the other day of somebody that was trying to stop in the rain, coming towards me. I was trying to turn left, and they had completely bald tires, no treads on their tires. How did I know? Because they slid so far, they were so close to me that I could actually see the tires that had no tread on them. And of course, if they had tires, they would have had much better adhesion. If you ever notice what a tire track actually looks like, they're not smooth. Most of us know what a tire track looks like. I'm going to kind of draw one. I don't know how well you'll be able to see that, but they're ziggy and zaggy. That allows for more places that have contact with the road and allows for more adhesion with that static friction. If your tires are bald, then you don't have anything to stick there, and so you're just getting that sliding motion. All right, the other type of, so that's static friction is when we want things to adhere, like when we're walking or driving. Sliding friction, we didn't get to, when we went ice skating, guys, down to Lock 3, sure, we wanted sliding friction down there, right? When we go sledding, which we really didn't get to do this year, did we? Really hardly was any snow this year. That would be another example of sliding friction. And then two other types of friction: rolling friction. Okay, anytime you have a surface that can roll on something that can roll on a surface, that's rolling. When you're rolling out some bread, there's not much bread in the store. We might be making our own bread or making our own cookies while we're home. I'm planning on making some cookies pretty soon, but rolling friction is when one surface, an object rolls over another surface. This is very common. The great thing about rolling friction, a bowling ball is a good example, right? That's a really good example. I like that one. How does rolling friction help us? How does it make things easier? Somebody give me an example. How rolling friction actually makes things easier. I can give one example if no one contributes. Recently, I had to take my car into the shop to get it looked at, and they were getting ready to put it on the lift. And so when they put it on the lift, they have these 4 arms that go underneath. The car was in neutral, which means it wasn't in gear, and so the legs weren't adjusted right. And so a 6,500 pound car, 6,500 pound car, we were able to move it just by 2 men just taking it and pushing it on relatively level ground. If that didn't have wheels on it, we would have never been able to budge it. Not even an inch, not 6,500 pounds. So wheels, well, things that we think about with wheels on, it makes our lives a lot easier to do things, right? When I broke my leg and sprained my ankle, I was wheeling around on that little knee scooter. That made my life easier by being able to move around quicker. Our cars, skateboards, if you guys are skaters, there's a lot of other applications. Spinners actually have little wheels inside them that help them to move real quickly. I have one here. I'll have to bring it next time. All right, so rolling friction is something that we're all aware of. We don't really think about that as actually being friction, but when something rolls across another surface, that is actually considered rolling friction, and it's very common. It's used all over. It's used in different applications in cars, in factories when they're packaging products. I told the example the other day. When I was young, I worked in this factory that packaged soaps. The soaps went into the box, and the box just went down a bunch of rollers. All you had to do was give it a little push, which is a force, a little push, and it just rolled all the way down to the end where somebody counted, taped it, stacked it. And that was before a lot of things were automated. And don't believe Mr. Murray, it wasn't the 1800s. So the last one is called fluid friction. Okay, your assignment that's going to be in there today is based on the 4 types of friction. And fluid friction is something that's a little bit more complicated because if I ask this question, what is a fluid? I'm interested in seeing what answer I'm going to get. So somebody give me an answer of what actually is a fluid. What is a fluid? And usually the answers we got are not wrong, but not completely right. What is a fluid? Anybody want to take a guess? Thanks, Rocky. So a liquid is a fluid. Absolutely. So any fluid that you can think of, water, a liquid. I gotta turn my phone down. Sorry. A water, a liquid, those are all definitely fluids. And those are all examples. Oils that we put in our car, fluids. The gasoline that powers it, fluid. It's been raining outside, fluid. So those are all right answers, Are they complete answers? No, because the air around us is actually considered a fluid too. And so the problem is we think that the word fluid and liquid are the same, and they're not. A liquid is something that if I open this, it would pour out. It doesn't stay in one place. Orange juice is another example of a liquid. Okay, that's another good example. Apple juice. But a liquid can also be the air around us. And so I don't know about you guys, but most of us like to swim or be in the water. So when you're swimming in a liquid, and that is the way that you move in that liquid is through fluid friction. So when you're swimming, okay, however you're swimming, doggy paddle, breaststroke, backstroke, right? Whatever you're doing, however you're swimming, if you're just kicking your feet and holding on to your floaty because you're not sure of yourself. Blood is a fluid too, yes. If you're not sure and you're just kicking your feet, right? Either way, you're moving in a fluid. So how is it that you move? Not a ballet dancer. They have fluid movements. That's right. Which means that's a different way of using the word. But when you're in the water and you're swimming, if there wasn't friction between your body and the water, you wouldn't move. So there is actually friction between your body and the water as you swim. As you pull your arms back, there's friction. Is it as much as it would be if you had a rope? That probably not, because there's resistance there. So how is the air around us a fluid too? Well, very simply, there is resistance in the air too. What I want you guys all to do is take a piece of paper, find a piece of paper, and just let it go, okay? And you'll find out that sometimes it'll fall rather quickly. Sometimes it'll fall kind of slow, okay? And you can do a variation on that by finding, again, take that and let it drop. Now take a book, any book, and put that piece of paper in front of it and let it drop. You're going to see a difference. It's going to drop quicker, much quicker. And so it's going to drop quicker because there's less resistance with it. Yeah, it's going to fall faster. Thank you. Quicker is quicker a word. I don't know. It's going to fall faster because there's more mass behind it, and it's solid. And so that mass cuts through that resistance or friction that's occurring. So we can take that piece of paper and drop it slowly, and it'll go all over the place, or we can put a book behind it. You will see a difference in how quickly it falls. But doing just a piece of paper by itself allows us to see that there actually is that friction in even the air. And so make your best paper airplane, okay, and fly it and figure out what works best. Now you're dealing with fluid friction. You've taught yourself something when you're talking about fluid friction. If you can make something that's going to stay in the air longer, that is an example of how you're efficiently using fluid friction. A balloon, yeah, a balloon, depending on if it's just filled with air, right, it's still going to fall to the ground. It's really light, and so the difference between, we're going to get into that a little bit later when we talk about the differences between the forces that are affecting things. Differences in forces change how quickly or slowly it moves, right? If I was standing in front of the room with Carmelo right now, and we had a rope, we played tug of war. Now Carmelo thinks that he would win, but what do I have going on my side? Number one, I weigh a lot more than him. And because, and because, so if we're equal strength, yet I weigh more than him, I probably have an edge against him, right? Because then my force will be greater than his. Doesn't mean that one of us is stronger than the other, just how we're using our forces. So there's always a battle. Yeah, this would be a good time to have Dave here because he is the airplane king. I could see him with a smirk on his face sitting in the back of the room, getting ready to fly one right now. And so those are the four. If you do have any questions about either of those, either static, fluid, sliding, or rolling friction, I'm going to give you guys a few minutes to come up with some possible answers or questions that I can answer. And if not, we're going to end it. And that's what our session is going to be. Again, in an hour at 11 will be 7th grade material. And then at 12 will be 6th grade material. Thanks, guys, for hanging out. Those of you who are not in 8th grade. I'm going to put my email up here. Make sure I spell it right. In case you guys have any questions during the week. All right, eat quick, Maddie. We'll see you at 11. All right, and Mr. Nelson is here. Very good. And so, like I said, I posted my email. If you guys have any questions, Mr. Fosnight, what time are you doing your session tomorrow? Do you remember? Maybe you can post that. And I will see 7th graders at 11, 6th graders at 12. These are going to be about between 20 and 30 minutes. So that's right where we're at. And that seems to be a good amount of time to give you guys enough direction to do an assignment. I'm trying to see if I have that up, Mr. Fosnight. It's in the email. Let's see. I don't have it up right now. If anybody has that and can post it before in my stream, that'll be fine. Go ahead and give that assignment a try. I have to go back in there and make sure I did it right. There's also a Quizlet in there for you guys to work on your vocabulary terms. There is a Google Doc that you can fill out. Your assignment is to fill out 5 vocabulary words that are the hardest for you to remember. My guess is that some of them may be differentiating the different types of bacon, definitely, different types of friction. Maddie, if you ask Mr. Fosnight or me, it would definitely be bacon. So you got our vote on the bacon. All right, so say goodbye to Harold. We always end with the same song. We're going to always end with the same song, aren't we, Mr. Fosnight? And I should have had this. Set up, right? So here we go. Don't sit around and do nothing. Do something productive. Help your families out. Do your homework. Do your packets. And stay safe. All right? All right, we're just ending up. We'll see 7th graders come back at 11. Get the message out. You guys always message each other. Get the message out to everybody that we're doing 8th grade at 10, 11th grade, 7th grade at 11, and 6th grade at noon. Tuesdays and Thursdays for science. Peace out.